So today's talk is about slices. Actually, it originates kind of from a discussion I had with Lede on like a lightweight state management for React, and this is kind of what I recommended. But going beyond that, I really wanted people who came to this talk to get more than just how to set up slices. I wanted them to see how slices can work together with TypeScript, with selectors, with sagas, and the different parts of the Redux ecosystem to really give you a lightweight and a really first-class experience. So with that out of the way, basically today we're going to focus on the reducers, which are the main part of slices. We're going to focus on selectors, which is how we get data from reducers. We're going to talk about unit testing, which is very important. Everything we do today is going to be unit tested. And then we're going to finish up with Redux sagas. So without further delay, I'm going to show you the simple little app we're going to build today. So this first part of this talk is just going to be building this counter. It's going to go up and down. But the counter is going to grab a Pokemon based on, whatever the number in the counter is. So the 24 in the Pokedex is Arbok, and 25 is Pikachu, et cetera, et cetera. So without further ado, I'm going to switch branches to master, which is the same branch that you guys are on. And we're going to get into this. So where's my chat? First thing we're going to do is install some libraries. I'm going to paste this into the chat, and you guys can just kind of copy paste this. What we're going to install is Redux, React Redux, the Redux Toolkit, Redux Logger, Axios, and Redux-Saga. So we can just hit enter, and all that stuff should be there. Even if you don't do this, it actually may already be installed in this if you've run Yarn before, but just in case, I included it here. And we're just going to hop right into it with selectors. Sorry, not selectors, with creating slices. So the first thing we're going to want to do is create a folder called Redux, and we're going to need to spell it properly, Redux. And then under Redux, we're going to create a couple files. The first one's going to be called number.selectors.typescript. Second is going to be called sorry, it should have been reducer.typescript. So number.reducer.test.ts. And I'm going to rename the other file to number.reducer because I named it incorrectly. At this point, what we're going to want to do is we're going to want to import a few things. Actually, you know what? Before we import anything, let's just get started by creating a type for our number state. So we're going to call our type number state. And we're going to say it's going to include a count, which is going to be a number. And that's all we're going to put in this for now. And we're actually going to export it, because later on we're going to need it for unit testing. I'm going to create another variable called initial state, which is going to be of type number state. And in here, I'm just going to make our count value equal to 0. Now's where the cool part happens. We're going to create our actual slice. So we're going to say const number slice is equal to create slice. Hopefully this will auto import for me, and it does. So inside of create slice, our first argument is going to be the name of the slice. We're just going to call this number. Our second argument is going to be the initial state we just created. And the final argument is where things get really interesting. So we have some people that are web developers in here who've done Redux before. For you guys, you're going to love this. So remember back in the day when we used to do like reducers and stuff, we used to have to create a function for the reducer. It would have a state, it would have an action. I'm just kind of pseudocoding here, don't type this out. Then you would have a super long switch statement, which would have like a ton of different things, and it would take a lot of time to maintain it. In addition to that, we would have to create an action, and then all of your actions would have like a type, and they would have a payload, and you'd have to create a file of like lines and lines and lines of these actions. It was super annoying to maintain. With slices, though, it takes like all of that away. You don't need to do almost any of that anymore. All you do is you create your action creator in the state, and it generates all that code for you. And I'll show you how that happens now by creating a couple of actions. So we're going to create our first action, increment count, and that's going to take in the state. And we're going to say state.count is equal to state.count plus 1. So again, Redux people are going to be like, what the heck? Aren't you supposed to be returning it like this, ... state, and then count is 1 or something? And no, actually with slices, all you do is you modify the state the way you want. And in the background, slices take care of all that immutability stuff for you. You don't have to do any of it on your own anymore. Now, for decrement count, we're going to do the same thing as we just did there, but we're going to say state.count is going to be equal to state.count minus 1, of course, because we're decrementing the counter. So now, to create our actions, it's as easy as just exporting things. So we're just going to say export const, and we're going to export our increment count. We're going to export our decrement count, and I typed that wrong. And we're just going to make that equal to number slice dot actions. Then we're going to export default our number slice dot reducer. So right there, our slice has just generated all the actions we need, and it generated our reducer. So now we're going to unit test all of this because, as we know, unit testing is super important. We're going to name our test suite number slice. And then we're going to make another describe. And we're going to make our first describe for increment count. First thing we're going to do is create an expected state, which is going to be of type number state, which we just created. And we're going to make its count equal to 1. And I'm going to add initial state at the beginning so that as we add things to the number state, it doesn't mangle our unit tests. We're going to say const actual is going to be equal to the reducer, which I need to import. The reducer acting on the initial state, increment count. And we are going to expect our expected value, our actual value to equal our expected. I forgot to write an it statement, so let me just write a quick one. It should increment count by 1. I'm just going to copy paste this in here. And I'm going to run our tests by just typing yarn test in the terminal, and hopefully we're passing so far. Awesome, we are. So the next thing I'm going to do is I'm going to kind of copy paste this test and create decrement count because they're so close. I don't see any reason not to do it that way. To do that, I'm going to import decrement count. I'm going to change this to decrement count, and I'm going to change the name of our test to decrement. And when I hit save, our tests should rerun. Oh, and I had to change the count to -1 because we're decrementing. We're not incrementing anymore. And our initial state is 0. Cool. So at this point, we're all unit tested up. We know that our reducer works, and we know that we can put values in the state. So the next thing we need to do is hook the app up to Redux. I added this section in because not everyone here is really familiar with the Redux store and things like that. So I wanted to show people how you set that up. In order to do that, we're going to need to grab a few things. I'm going to import combine reducers. I'm going to import configure store. I'm going to import our number reducer, and I'm going to import the Redux logger. Next thing I'm going to do is I'm going to create a combined reducer, which is usually the one you use for the app. I'm going to create it using the function combine reducers. And I'm going to set the key for number because our number reducer handles numbers and Pokemon numbers. And its value will be number reducer. Next thing we want to do is we want to create the store using configure store, which is probably pretty self-evident from the name of the function. Oops. First argument, of course, is going to be the combined reducer we just created because that is the only reducer that we have here that can go in it. Second thing we're going to do is we're going to add middleware. So middleware exposes a function to you. Oh, should this be reducers? 1 second. I may have made a typo here. Reducer is combined reducer. Okay, maybe I didn't. Maybe it's just mad because of the middleware thing. And within middleware, it actually returns you a function called getDefaultMiddleware. This is the default middleware for Redux. So whenever you modify the middleware, you always have to put the default Redux middleware in before you add your own custom stuff. So we're going to say default middleware equals getDefaultMiddleware. Then in order to have our middleware actually get used, we're going to have to spread our default middleware into the store. And then we're going to need to add the logger. Next thing I'm going to do is export default our store. So in order to use TypeScript, I'm going to give you another little copy-paste pasta here. This actually comes from the Redux slice people. They recommend you do this so that the Redux slice actually infers the type and you don't need to write the type yourself. So there's no real thought here. Even when I did it, I copy pasted it. I didn't, write anything particularly innovative. I'm going to paste this in the chat for you guys so that you can just paste it as well. Then you just have to import use dispatch for this to work. So now what happens is whenever you use the store, your root state will be created based on inferring the type of the store from combined reducers. So if I was to add a new reducer here called like cheese or something, it would add cheese to the root state type, and later on, you can use it with your TypeScript. It'll become more obvious as I go along why this is important, but for now, you can just kind of copy paste and trust what I have here. All right, so next step, we're going to hook it up to the app by using the provider. Nothing much to talk about here. We just want to make sure that the app is actually wrapped in the provider. And we want to supply it a store. It's going to be equal to the store that we just created. Cool. So now in our home screen, which I've already kind of prepared for us, we should have full access to Redux. So people who've done Redux before, you're going to be used to this syntax, seeing connect, then map state to props, and map dispatch, or whatever, then wrapping home in that, then passing all the information in through the props. This is another Redux thing we don't do anymore. Connect is dead. Long live hooks. So in order to get like our dispatch stuff from the Redux store, what we need to do is get the dispatch function hook. We're going to say const dispatch equals use dispatch. And then we just need to create functions that use this dispatch function from the provider in order to actually dispatch things into our store. So we're going to create a function called increment dispatch, which is going to use dispatch. And we're going to call increment count. When we do that, we're going to create another function called decrement dispatch, which is going to be equal to the dispatch function again, called on decrement count. So at this point, I'm actually going to plug this into the app. We should hopefully see some stuff work. You're not going to see the counter go up or down, but in the logger, oh, I have to make this a function. I apologize. This was not a function. In our logger, you should actually be able to see the counter being incremented and decremented. So let me restart server. That's just going to take a quick second. Still restarting. I'm going to go to inspect in my side tab just so I can see the console. And when I click increment counter, the count goes up. If I decrement twice, we'll get 10. The count's going down. Awesome. So at this point, we're now taking information and we're putting it into our reducer, which holds the state of the application. The question now is, how do we get that information with slices? And the way that we're going to get that information is with something called selectors. So we're going to create a new file called number.selectors.typescript and another folder called number.selectors.test.typescript. And I'm going to put these side by side. I always have the test on the right and the code on the left. I don't know why. Maybe I'm just superstitious, but that's always the way I do it. So I'm going to import the root state from the store. And in order to get the value we want from the root state, we want to create a function that does export const. We're going to call it select count from the state. And then we're going to say the state is of type root state. And we're going to return state.number.count. And that should give us the actual count. And we're going to unit test this as well, as we always do. We're going to name the test suite number selectors. We're going to make another describe statement, which is going to hold the name of the function that we're actually testing. And inside of here, we're actually going to name this should get count from the state. And we're going to make a mock state in order to do this. We're going to say const root state is equal to a root state. Inside of root state, we're going to have number because that's the name of our reducer. In here, we're going to spread our initial state, and we're going to make our count equal to 5. It's just a random number I picked, but it's useful for these purposes. So we're going to expect the number that comes back from the selector to be 5, because what selectors do is they pull data from the state of the application, and we're going to see if this actually works. So in const actual, we're going to say select count. I'll put an equal there. And I'm going to do it on the root state. And I'm going to expect actual to equal the expected. And I need to import this, of course. And then I'll run the tests. And we'll see if we're still passing. Hopefully that's the case. Sick. All right, we're still passing. So now, again, let's go back to home and let's actually put this count in the screen. So for you guys who have done Redux before, again, you're used to having selectors and having the map state to props and getting stuff to come in through the props. Again, no longer a thing. We're just going to use hooks for that. We're going to say const count is equal to use selector. And we're going to say select count, the function we just created. We're going to plug count into here. And hopefully we should see the number come up. Start our server again. By the way, guys, if oh, how come my state's not loading? Okay, give me a quick second. I got to figure out why I'm not seeing the count. Oh, we are seeing the count. Awesome. So because of the selector, we can now retrieve the number from the state, and everything works just fine. So that's part one. I went through that pretty quick because I expect that's pretty straightforward, kind of how that whole Redux loop works together. It's really just how Redux worked before, but with a lot simpler syntax. I'm going to try to slow down a bit for the next part where we actually fetch data from the API. And hopefully that's pretty straightforward. But I expect most of the questions to come from this next part and not so much this first part. So in order to get the Pokemon, we're going to need Redux-Saga. So we're going to create a file called number.saga.typescript. Unfortunately, today, I'm not going to be unit testing the Saga. Sagas are a little bit complex to test, and it kind of would have gone over time, so I had to cut it. But if you guys are ever interested, I can go over it one-on-one at a later time. So we're going to create a function, export function star root number Saga. And what Sagas do is they're also a middleware, kind of like the logger. They listen for Redux events. And whenever they see an event come in our case, it's going to be for fetching Pokemon. What we're going to do is we're going to then put the Pokemon in the actual state. So by the way, guys, is my video working fine so far? I just want to make sure that everyone's seeing what I'm doing and everything's all right. Is everything okay so far?
Yep.
Awesome. Cool. All right. So then I will continue. And we're going to say fetch Pokemon Saga. So we're going to listen for a certain event. And when that certain event happens, we're going to call this fetch Pokemon. But before we come in here, we have to do a little bit of setup. And so I'm going to show you guys that setup now. So we're going to create a new folder called models that's going to handle our Pokemon model. So within models, we'll create a new file called pokemon.typescript. Our type Pokemon is going to have a name, which will be a string. And it's also going to have an avatar URI, which will also be equal to a string. And we're going to export default our Pokemon type. And we're going to use that in the reducer in just a minute. So now in the reducer, we're going to want to update our state so that we can, fetch a Pokemon. So I'm going to put my tests back on the right side so that we can do that testing. We're going to add a flag to say whether or not we're fetching Pokemon. We're going to call it isFetchingPokemon. It's going to be a Boolean. And we're going to create another value called Pokemon, which is going to be the Pokemon. and it's going to be of type Pokemon or null. In our initial state, we need to update that. We're going to put the fetching Pokemon false in the initial state, just because, of course, we're not fetching a Pokemon when we start the app. And we're going to set the value of the Pokemon to null when we start, because we don't have a Pokemon right away. The next thing we're going to do is we're going to create an action for actually fetching the Pokemon. We're going to say state.isFetchingPokemon is going to be equal to true. So we're not actually going to get the Pokemon with this action. We're just going to set up the web request part, and we're going to export that. This section here will be very relevant for sagas in a minute. It seems like a weird thing to do, but whenever you are loading from a web request, it's always important to have state to say you're going out to get something, or you need state coming back, just so that you can create a loader or something like that, like a loading spinner if need be. And last, we're going to create an action called fetch Pokemon success, which is going to handle what happens if a Pokemon comes in. This function is going to take in state and an action, which is a little different from what we've seen so far. So far, I've just been setting the state manually. What the action is when you want to pass data into Redux from a screen or from a saga or from anything else, you pass data in through the actual actions payload. So the Pokemon, state.Pokemon, is going to come in through the action.payload. And we're going to set our isFetchingPokemon state to false, because if the Pokemon thing succeeded, you of course are done, and you can set that to false. You could also do an error state. We're not going to do an error state today, just because of time constraints, but I think it's pretty easy to see how we could extrapolate that into error states later on. Okay, so let's make some unit tests for this. So we're going to say describe fetch Pokemon. We're going to say it should set fetching state to true. Oops. Out of here, I'm going to create an expected state, as we have many times already. Number state. And the the isFetchingPokemon is going to be equal to true. And at the top, I'm just going to go ... initial state, because I don't want any state in the initial state to change other than the fact that isFetchingPokemon was set. And our actual is going to be equal to the reducer acting on the initial state, and we're going to call fetch Pokemon on that. I'm going to copy paste the actual is equal to expected, because you guys have seen that already a million times, and sure we don't need to be reviewing that. All right, so we get another passing test for fetching Pokemon, and I'm going to create our final test for success. So if our Pokemon fetching actually succeeds, I'm going to say describe fetch Pokemon success. And we're going to say it should add a Pokemon to the state. First thing we're going to do is create a Pokemon. I'm going to make this first one's name Onyx, just because Onyx is easy to type, not for any other reason. And the avatar URI is just going to be image.com, because it's, again, easy to type. So our expected state, type number state, is going to be equal to the initial state value, but the Pokemon value is going to be equal to the Pokemon we just created, and isFetchingPokemon should now be equal to false. Final thing we're going to do is say actual should equal the reducer acting on the initial state, and we're going to call fetch Pokemon success for that. But inside of the fetch Pokemon success function, we are going to put our Pokemon as a parameter. So we should be testing if this action goes out with a Pokemon. The Pokemon should now be put into this state. So we can confirm that through this test. I'm going to hit save. Hopefully we're still passing. And we are. Cool. So I know looking through all these tests is a little bit boring, but it's kind of an important part of showing how this whole flow kind of works together with slices. I have one more combination of selector test for you then we'll write the saga, which is probably a little more exciting for everyone. So in our number selectors, again, I have to put it on the left always because I'm superstitious about that. I don't know why. We're going to go export const select Pokemon. This is going to get our Pokemon from the state. And our state is, of course, of type root state, as we all know. We're going to say state.number.Pokemon is what we want. And I'm going to copy paste this test so I don't have to rewrite all the state stuff again. I'm going to call this select Pokemon. It should get the Pokemon from the state. I'm going to create a Pokemon similar to what we created earlier, with the name as, again, Onyx, and the image or avatar URI equal to image.com. In our state, I'm going to put the Pokemon just as itself. And then what I'm going to expect is that the value will be Pokemon, and that when we select Pokemon off the root state, we're going to get the Pokemon that we did up there. So let's see if that's the case. Awesome, it is. So now we have our Pokemon. We can put our Pokemon into the reducer, and we can get it out with a selector. We have kind of the building blocks now that we need in order to make a saga and actually fetch something from an API. So let's come back to our saga here that we created earlier. And I'm going to import a few things from Redux-Saga so we can get started. First one's called take every. This is what allows us to take every string action from Redux and to use it in our actual store. This next is going to be put, call, and select. I'll be using these other ones later. You don't have to worry about those right now. So I'm going to say yield take every, and we're going to listen for the fetch Pokemon type coming from the Redux store. And whenever we see this action come through of fetch Pokemon type, we're going to call the fetch Pokemon saga. For now, I'm just going to console.log here, so we can see that the saga is actually listening for this information and that we're getting in there. And I'm going to set things up in the store right now so that we are able to do that. So the first thing we want to do is we want to create a root saga. Our root saga is going to be a function star root saga. Inside of there, we're going to say yield, and I'm going to import a couple actions. Just realizing I forgot to do that. I'm going to need all from Redux effects, and I'm going to need fork. So I'm going to yield all, and inside of all, I'm going to fork our root number saga. The next thing I need to do is create the saga middleware. I'm going to create a variable called saga middleware and import create saga middleware as well while I'm in the process of that. And I'm going to add this middleware to our array of middlewares, just like I did for the logger. And then I'm going to get the saga middleware to run our root saga. Okay, so for this next part, I'm going to do a little more copy pasting of some HTML. This is just layout code. It's not any like actual Redux stuff that you need to do or think about. It's literally just HTML. It's pretty kindergarten, so I'll just paste this to you guys so that we can all use it. You'll find it in the chat right now. So I'm going to paste this in, and I'm going to comment out all the areas that rely on any kind of home screen data. And I'm going to create this function for fetching Pokemon. I'm going to call it const dispatch fetch. And I'm going to make it equal to dispatch fetch Pokemon. So actually, I'll call it dispatch fetch Pokemon. It's like I have it called here. Copy, paste. So now, if I run the app, I should be able to see that button. And when I click on the button, I should be able to get into the Redux Saga and see the "you are here" appear in my console. So if I click, we see "you are here." So again, to explain this, every time I click Get Pokemon, the Fetch Pokemon action comes, and our Saga listens for that function to come, the fetch Pokemon action, and it calls this fetch Pokemon saga whenever that happens. All right, guys, so we're getting right at the end. We're in the final steps. Here's where the fetch actually happens. I've got one more little copy paste for you before we move forward. And it's just the URL for the Poke API. I'm going to put this in the chat as well. And so we can just copy paste that in. It doesn't do anything special. It's just a URL. And we're going to give our fetch Pokemon saga a type. It's going to take in any action, return void, and its call function works on a string. So these are the three things we need to put there. Do I need to import any action? I don't think I do I? 1 minute. I do need to import any action. All right, I'm going to import that now. Okay, so now that I have it, I'm going to get the number of the Pokemon that's in the counter. I'm going to call that Poke number. And it's going to be equal to yield select. And then I'm going to call select Pokemon, select count inside of yield. So that's going to give me back the number of the Pokemon. Next thing I'm going to do is create our fetch URL. It's going to be equal to the string concatenation of the Pokemon URL and the Pokemon number. And I'm going to actually get the raw Pokemon data from the API. I'm going to do that using yield call. I'm going to do axios.get. I have to import Axios, of course. Forgetting to import things. And I'm going to call that on the fetch URL. And what I'm going to do with this data is I'm going to create a Pokemon object. In that object, I'm going to say the name is equal to raw Pokemon data dot name. Oh. And then this other one I memorized, so you'll just have to copy me. There's no technical reason to know this, but the avatar URI is the raw Pokemon data sprites front underscore default. So this data thing is yelling at me because it doesn't know what form Axios is coming in. For now, I'm just going to set the type of any because I'm kind of custom making this Pokemon on the fly, and this is not really what you're supposed to do, but I did it here because it makes things simpler for the purposes of demonstration. And where this is finally going to round out is we're going to do our fetch Pokemon success function. Oh, sorry. We're going to do yield put. Inside of put, we're going to do our fetch Pokemon success function, and we're going to throw our Pokemon in there. So what this should do is the Redux middleware is going to listen for fetch Pokemon. Fetch Pokemon is going to call fetch Pokemon saga. Inside of fetch Pokemon saga, we're actually going to get the Pokemon. And using our slice action creator for fetch Pokemon success, we are going to actually put that Pokemon back in the state. So right now, if I run the app, that's hopefully what we're going to see. Let's see in our debugger if that's the case. So I'm going to increment this a bunch of times. I'm going to whip into our state. And under Pokemon, we see name Kakuna, and we see a URL. So we're almost right at the end here, guys. So we're at the final step. Last thing we're going to do is we're going to get the Pokemon from the state. We're going to do that using the select Pokemon selector we created earlier. And we're going to uncomment these couple places where I had Pokemon data. You're just going to delete home screen data. It's something else I wanted to show, but I cut it out because my talk was taking too much time. And then for the second one, change avatar for avatar URI. And at this point, hopefully, we should be able to actually grab our Pokemon from the state. Okay, so that kind of concludes everything. I know there was kind of a lot, but there was a lot in the actual Redux ecosystem that you have to fit in with slices in terms of how you get data, how you do asynchronous calls, how you do all these different types of things. I'm expecting a lot of questions, so if you guys have questions, feel free to ask them now. I'll answer whatever you guys like.
When we integrate with some tools, like for example Storybook, usually one approach that I used to follow with like the typical Redux setup was like to export the connected component and the raw component, the non-connected one,
Yep.
in order to expose through a storybook the non-connected one, and being able to basically pass through like the data that I choose without having to actually instantiate any Redux store or mocking any of the Redux setup in order to make it like physically work or visually work. What is the approach that you follow with this so it does not kind of break when you instantiate it without a Redux setup?
Yeah, so right now I haven't had the chance to set this up with Storybook before, but I think what you would have to do is you would have to make like a mock provider and wrap your actual instance of the component in that mock provider with a mock store. I'm not sure there's another way. When you use hooks, everything has to come from that higher order component kind of at the top, and you need the context of that component in order to get like dispatch and to get use selector and things like that. So I think you would have to mock out the store at some level in order to make that work.
Okay.
Yep.
And when a component has to be connected to multiple selectors,
Yes.
how
That, that's
how
the
you
part that
find?
I cut, but I can do a pseudocode for you to kind of show you how that works. I'll go really slow with the pseudocoding. I won't have as much to fit in here. So let's say for the home screen, we wanted to create like a big one with multiple data from multiple places.
Mhm.
What we would do is you'd create something like home.selector.typescript. Inside of there, you would use reselect. You would say const home data or something is equal to the structured selector. Inside of there, you would say whatever your data was going to be. So if it was like the Pokemon, you do select Pokemon or whatever. And then for every single selector from every different source of data in your Redux state,
Mhm.
you would combine all of your different selectors in the structured selector.
Mhm.
And in the home data selector, you would just paste that into here. You could destructure all of it in there, like Pokemon, count, anything else you wanted. And you'd only need one use selector call, and you would have them all combined and create structured selector from reselect.
Mhm. Cool. Cool. But we'll be able to hear like the updates from a second level. Like what I mean is like what you are returning is an object at the end of the day.
Yeah.
So like the reference to that the different properties of that object will be updated, so it will figure out that something changed, isn't it? So
Yep.
is well thought is what I'm trying to ask.
Yeah. So reselect is kind of optimized for that already. Reselector will detect if there's a change in any of the state objects that you're actually trying to select data from, and it won't re-render everything unless something's changed in your actual selectors here. If for some reason you wanted to break them apart to render at different times, I'm not sure it would make a difference because you still have to re-render the screen no matter what state you're touching. So I think if you were to do it through create structured selector, that would probably be the best way because everything's in one JSON and structured selector is kind of optimized to pick out state from different parts of the Redux state and rebuild them into a little map for you.
Okay.
Yep.
Cool. Thank you.
Oh, no problem.